Hey everyone, welcome to the stream. So yeah, I've haven't been streaming as regularly for the last week. It was spring break last week, so I took the time to spend with my family. But now I'm back, so yeah, let's get to it. Alright, so last time, which was about a week ago, when we were working on Vectrexy, we had basically gotten, let's see here, we finished implementing a bunch of stuff to get here, implement simulate 3D imager, and CPU properly set interrupt mask bit to 1 on reset. So yeah, we did a bunch of interrupt related stuff, and we were able to get the game Bedlam mostly working. And I say mostly because what we saw, I'm just gonna get that running again. What we saw is that we can play it and everything looks like it's working until we die. And then when we try to start a second round, a second new game, then we have this problem of this being this like a little white dot in the middle. So here, we'll fast forward through this. So this is the game. So here you see it's working. So this here you can go and we can shoot baddies and all that. And this works fine. But then, let's say I fast forward and die. It says end. And then on the next round, we're here, and we're stuck, and nothing's happening. So yeah, I'd like to get this working if possible. And I was thinking about it, and I was thinking what I'd like to do is I'd like to make use of the sync protocol stuff that I implemented, where we compare the CPU, my CPU implementation's execution to that of Vectrex, which is another emulator. So I'd like to do that, but before I do that, I just want to see, does this game work properly in Vectrex to begin with? So that's like one of the first questions I need to answer. So let's see if that's the case. So here's Vectrex. Now, if I recall, we run this, there was like a parameter for Vectrex. It's -C, was it, for cartridge? Or -cart? Okay, so you should see that. But I think that's not right. I got an error. Maybe I'll take off the quotes. Cannot open. Oh, I think it's because of the space. Something annoying about this emulator. It doesn't like names with spaces in them. Yeah, that's why that's it. I see for pole position I had done the same thing. I had moved it here. So let's do Vectrex. Still doesn't like it. Oh, it's the quotes. Yep. Alright, so let's just see if this works. I don't think there's a fast forward key that I can use here. Yeah, so I'll just let myself die. Okay, so we're ending here. Hey, look at that. Now that's interesting. So Vectrex has the same bug I do. Huh. Alright. Wasn't expecting that. I think, let me see, did I actually grab the VDay or Vids emulator? Let me see here. Sorry, I'm a little bit off the screen here. I'm just looking to see if I had downloaded. I think I have Vid somewhere. If not, I'm gonna just download it again. I'd just like to see this working in another emulator. Okay, here, let's look for it here. So it's Malban. Alright, so it's going to take a little while. So, I wonder what the problem can be. And it's interesting that, so if I'm having this bug and so is Vectrex, I guess it must be a fairly common bug. So this, you know, and my guess is it's related again to interrupts. Because when we didn't have interrupts implemented correctly, now what was again the fix we made? Oh yeah, that's it. If we didn't reset the interrupt mask correctly to 1, which means no interrupts allowed, that dot thing would occur right off the bat. So we could try that just to see if we can make some sense of this. So basically this interrupt mask, if it's set like this, it means when we start, interrupts right now are not allowed. And if we set it to 0, it means, okay, now interrupts are allowed. And what I had found was that if I had started it with 0, specifically for Bedlam, we would get that white dot in the middle. So let's see if that's still true. So there we go. So we're in this state. So it almost feels like as if when we die, something should have reset it. And I wonder if it's that maybe what it is that we're not handling the reset interrupt Is that this is what I was saying last time. Is that even a thing? Can you invoke? Is there a way to even invoke that? I know hardware-wise, if you press reset, that's what's going to happen. But software-wise, can you force the reset vector, the reset interrupt to occur? I wonder. Like basically what I'm wondering is the game doing something when you game over and you hit the key to continue that would expect to basically reset the interrupt mask back to 1 before proceeding? So you can see it here that it's high. Now it's high, but it's like too late. It would have had to have been set to high. Let me see. See, when I do reset now, it's low, which means it's 0, and something sets it to 1, but like it's no good anymore. It's like at the wrong time because some other interrupt service routine ran before and messed up the state. So still low. Then we go like this, and we're screwed. Oh, look at that, still low. Okay. And then something set it to high. Probably what that is that when the interrupt service routine that just ran finished, it sets the interrupt mask back to 1. Yeah. Like here. Something happened and it set it to 1. It's running an interrupt service routine. Yeah, so basically, if we start with the mask set to 0, there is some other interrupt that occurs, which is not expected to run first, and then that's running, and it's screwing up everything. The game is expecting it to be 1, and yeah, that my theory is that this has something to do with the fact that the game is probably trying to do a reset. How can you do a reset? I don't think there is a way, is there? Oh, there's this. But it's not calling reset, is it? We would have gotten this unhandled op, right? X3E. We're definitely not handling it. Just double checking here. If we would have grabbed that instruction, we would have checked the number of cycles is greater than or equal to 0, because this is the only one I have left that has a negative number here, because I have not implemented it yet. Or we would have entered this default case here. Do I have this in all 3? I do. And we did not hit that, so it doesn't look like it's calling reset. But definitely there is a way to do a reset. I think now I must have downloaded this here. let me just copy that into my... Put it somewhere. Oops. I'll go to emus. Oh, I could also try para JVE. That's true. Let's see if this actually works. Oh, looks like I'm missing some chats here. What's going on? Sorry guys, my dashboard is not working. Well, I see here Lisp Gamer wrote, I seem to remember trying to fake a reset on 6809 and having to clear the global IRQ enable flags. Just give me a second, okay? I want to see if I can get my... I don't know why my chat's not working here. Just gonna refresh my dashboard. Maybe that'll do the trick. This dashboard in Twitch can be a little bit flaky sometimes. Get it to reconnect here. So if I've missed other chats, I'm really sorry about that. I don't know if there were other messages. Ah, it's not showing up in... What's going on here? I see it showing up like on my OBS because I have it displayed, but it's not showing up the actual chat dialogue on the Twitch dashboard. That's really crazy. Let me see here. Yeah, I see Pyro, you wrote test and Lisp Gamer, I just thought you were being... Yeah man, so sorry. It's not working in here. Let me try something else. Let me go... How do I make this work? Okay, just one second. Okay, I'll be right back. Just give me a second. Hey guys. So I really don't understand what's going on. I'm trying all kinds of stuff, and the chat is definitely showing up on, like, for you guys on OBS. You know, like I see what you guys write to me there, but in the actual chat room on my proper message board, sorry, on my proper dashboard, it doesn't work. Oh, okay, it just came back. I actually killed Chrome and just started it again. That seems to have maybe fixed it. Well, that's annoying. So sorry about that, guys. Sorry if I didn't respond to the hellos. Yeah, no idea that you guys were writing to me. So let me get back to my dashboard here. See if that works now. Technical difficulties. All right. Okay, now it's working. Okay, so sorry about that. Let's see if we can get this thing working now. So I'm gonna load this Para JVE, which is actually an emulator I haven't really used much of. Okay. Pick another ROM. Alright, so let me pick a ROM. So we want Bedlam. No, not the spinner hack. Oh, thanks for the follow. No Nos Travelociraptus. Sorry if I butchered that. Okay, let's see here. Okay. I said run game, but don't see anything running. This is a stream of technical difficulties. Is it running? Alright, it looks like that it died. Let's try it one more time. Maybe it didn't like my path. Let's try browsing to it. Pick another ROM. Bedlam. Okay. Oh. Okay, that's fine. That's interesting. Oh, okay. So now it's working. Hey, it's pretty cool. Interesting. Interesting, like, little jitter effect. Alright, Bedlam. Oh, very nice. I guess we'll hear some sound. Cool. Nice little glow effect. When does this actually play though? seems to be hanging for a long time on this title screen here. Does this work? I'm wondering if Bedlam is one of those games that just causes like a lot of emulators to not, like, maybe it's one of those ones because of the way it interacts with interrupts and stuff. Maybe a lot of emulators don't support it properly. Does this like load a save game? Yeah, let's try another ROM. Yeah, I don't know, it's not loading. This is another emulator, right? So just want to see if something works in here. Let's try Scramble. Oh, okay, that works. Got music and everything. Wow. It's not looking good for this emulator. Alright, forget it. It's not working. We'll try it. We'll try now VD or Vid, or I don't know how you pronounce it. Let's see here. Kill this para. Is it like Java or something? Alright. Okay, so this one's really cool. I don't think I've shown this yet on stream. So this is Malbin's really awesome tools that he put together. It's an IDE for making Vectrex games and to actually be able to program them yourself. Okay, check this out. Whoops. Like, this is quality, man. You've got your screen here. You've got like, I haven't really explored all of this, but it looks really powerful. You've got like a nice disassembler and actually a proper ROM view, and you can put breakpoints and all that stuff, and it's visual. It's really nice. But right now I just want to see. Yeah, I see you even have like which inputs you want to put in, light pen emulation. It's really cool. Joystick, keyboard, key set. Yeah. So let's go and grab Bedlam again. So we loaded it, and now we do play, if I recall. Yeah, this thing is sick. It's really cool. So you've got the audio emulation and everything. I love the CRT curve. Yeah, it's awesome. This is quality right here. Okay, so I'll just let myself die, and we'll see. I suspect this will work. This is probably one of the best emulators, if not the best emulator out there. Yeah, it's really good. Yeah, this one works for sure. So you can stop like this. I don't know if you can from here. I haven't really played with it too much, but I'm guessing you can like start stepping and seeing the code and all that. Like here I know there's, yeah, see here you have like, this is actual source. But I don't know about like debugging an actual ROM. Anyway, I'm not gonna figure out V-Day right now, but anyone who's interested in doing Vectrex, writing Vectrex game, this is the tool you want to grab, and it's actually works on Windows, Mac, Linux, because it's built on Java, so that's really cool. All right, so this kind of sucks because I can't really use the Vectrex integration stuff that I did, because we saw it doesn't work on the second round there. I'm wondering if there's like another way. I mean, there are multiple ways to set that flag, right? Only tools for next gen could be as good. Yeah. Yeah, I was wondering about that. I don't know if so first of all, that requires me to actually learn how vid works. So we can like mess around with it and try to learn how that works. It also means, you know, seeing if it supports some kind of like conditional breakpoint on a flags register change, which I'm not sure it supports that either. It might. But I was thinking more on my end, when we finish, to see if there is actually an instruction that tries to change the flags register and what that might be. I mean, it seems odd that I wouldn't handle that. And of course, I'm still kind of making a guess here as to that being the problem. I just had this thought, maybe it's related to FIRQ? Like, I don't have any way of knowing if a fast interrupt request is being fired. And I'm trying to remember, what is it again that sets FIRQ? Do I have my... That was on my to-do. Did I write something here? So I know that IRQ, let me see here, IRQ enabled, we get that from the VIA, and I assume it's the same thing for FIRQ, but I don't have anything, I didn't figure out yet how we know whether FIRQ is set. Oh, that's right. It's it's gonna be port 0 button 4. Yeah, so that's So that is possibly it's possible that this might cause the FIRQ to fire. Isn't it button 4 that we have to press to continue? Let me just take a look here. Oh wait, I gotta undo my change in the CPU. So when we're here, no, see, button 4 is not what we pressed to continue. It looks like it's button 1. Ah, but then to actually play it is button 4, so maybe... Yeah, it's possible. Okay, so if that's the case, I mean, it should be pretty easy to check this out. Port 0, button 4. We're going to do something very similar to how we're handling FIRQ. So this is actually simpler. So why don't we see? I guess I could do... So I think just setting it to equal exactly to when the button is down, we'll say to true, otherwise it'll be false every time we do an update on the VIA. That should work. And then on the debugger side here, we'll say FIRQ enabled, so pass that in to execute instruction. Every time I write FIRQ, I write fire. Okay. And it'll be something like, if this is enabled, and then here we want to just break for now. Thinking about one thing we could do to see if FIRQ is what's being used is in that other emulator would be to see if that interrupt vector gets called in the FIRQ. Like we can go look in memory to see what where that interrupt address is and put a breakpoint there. So that would be one way to check. Again, though, I need to learn how to use VDay. Oh, why didn't it like this? Oh, because it's optimized. Still no good. Okay. So I'm not hitting that breakpoint, and I mean, I guess I shouldn't be too surprised because I think it's F here. You see that F is high. I don't think F is ever set to low. It would be cool if I could put a watch point on that. We could do is something else. We can do this. In execute instruction here, let's do this. Just curious if there's anything that actually sets it to 0. Alright, so it's not that. Alright, so let's see. If we take a look now at the code that it's running, maybe we'll get a hint as to what it's doing. Oh, and actually, let's load our symbols again from where. There's a task that I have in my to-do list that I really should just do at some point because I keep going through this. It's this load and execute a startup script, where every time I launch my debugger, there's always a set, you know, like I'd like to have like a file with, here are some instructions I want you to execute every time we start up, and one of them would be to load the symbols that I need from the BIOS or from anything else. And right now I don't have that, so I keep doing it manually, which really sucks. And I don't even remember where it is. I always forget where I put that. Is it this one here? Symbol table, I think it's this one. Is that where it's stuck? Branch if equal on a bit on port A. Yeah, you're looking here. You're looking at this here. I don't think this is where it's stuck. This looks like it's looking at T00D. This looks like the typical waiting for the timer to finish every frame so that it can keep at 50 Hertz. There's always this kind of like recalibration loop on the Vectrex. This is a very common thing that we see once per frame. So it's really the code in between that we're going to take a look at. Okay, I'm just going to run a little bit. Redump my trace, this time with symbols. Yeah, you'll see what I mean. I'll just, once this is finished, we'll reload. And then here we should see that it's looking at the timer. Okay, so let's see, it's looking, yeah, it's hitting this, the flags, the interrupt flags, and it is looking to see if bit A, so A is 20, so it's looking for, what is that, that's bit 5, is it? Or 5? Yeah, I think it's bit 5. So bit A in the do register, the interrupt flags. So there, that's timer 2. So yeah, it's looking for timer 2. Timer 2 is the one that's typically used for the frame timer. Look here, my timers. Timer 2 is used mainly as the 50 Hertz game frame timer. F1A0 is BIOS ROM, right? Yes. That's right, Pyro. You're starting to get to know the Vectrex. That's cool. So exactly, what you're seeing here, we're right now in a BIOS routine. All right, so let's move down a little bit out of this kind of wait loop. And then we get back to normal code here. So see, at one point, we have the dude register has 44 in it instead of 4. At which point now branch if equals actually does the branch that it wants to do, which would be go to F3 3D, is it? No, it's branch. Okay, if it's not equal, then we don't branch to F3 3D. Instead, we now go to F3 4 1. Here we do some decrementing of A to 0 here, and we do return from subroutine. So we're still in that BIOS routine, which is this recalibration routine. This is all part of it. Reset 0 ref is part of it. And then finally we return and we come here. And so this is the part where we are now back into the ROM at 04DA. And you can see here now the next thing it does is it reads buttons because it's waiting to see for button presses. That's interesting. The thing that I worry about is that like we're already in a messed state and we're not going to understand what it's blocked on. We'll keep looking, but I fear we're not going to see what we want to see. And I think it's because, ultimately it's because this, I think it is because this interrupt mask flag should have been set to 0, maybe through some kind of reset routine. And instead we had some other interrupt run and set it back to high, and now basically we're blocking the interrupt that we require for, I think, for rendering or for maybe doing that effect. I don't know for what. Like maybe right now if I force it, we could try that. We could just try and force it to 0 and see what happens. In fact, you know what, that's a good point. Would we process an interrupt right now? Is the IRQ enabled on the VIA at this moment? We can check that. We go into CPU, no, debugger here. Okay, well, right now IRQ is returning false, so that's not helping us at this moment, but that doesn't mean anything. Let's go into X construction here, and okay, we're right now on the CPU. Why am I not hitting any of my breakpoints here? There we go. Okay, I'm just gonna force the interrupt mask bit to 0. And nothing's happening. Oh, I got set back to 1. So we probably handled a different interrupt. Right now we're just messing things up. We can't just arbitrarily do this because it's all, you know, the CPU, there's a certain point where it says, I now am waiting for an interrupt so that I can handle it with a certain service routine. So this is not going to help. I think we're already in a messed state. Okay, let me just see what's happening in this code. Joy Digital. So what I'm doing is I know that this is all BIOS code, so I'm just going to skip until I see that we return. There we return. And then immediately we do an intensity 5F. So this sets the intensity of the screen. What I should do is I should do this. Look for the next $0. Okay, so then we do sound. Then we do a bunch of stuff in the ROM itself. And we set the intensity to 3F. We say move to D7F, so this is to move the, for rendering, we're going to move the beam. Next one, come back. So here we're drawing. Come back. Another draw call, another move the beam call. Here another draw. Move, draw. And then once again intensity 5F. So I think this is the loop that we're seeing. Oh, here's a print string, so that probably is like the score, the string that we see at the top. Because we see it's rendering this here, it's rendering level, it's rendering how many guys you have, but then it's stuck. So okay, let's say that's what this print string is doing here. Another move, print string YX, move. Clear X to B. DP to C8. Transfer A to DP. So this puts C8 into DP. Sets DP to C8, okay. Rise, run, index, another BIOS routine. Rise, run, index. Let's take a look at what that means. This routine gets the index pair for both the rise and run using the passed-in angle value. Ah, okay. See, that's interesting, right? That gives me the impression that it probably wants to do that to start drawing the screen that we're not drawing based on angle. That's interesting. Okay, so we run this, come back. Now we set DP to D0. Usually when we do that, it's because we're back to dealing with the VIA. Because usually DP is D0. And D0 is the first address, the high order address bits for the VIA memory map registers. Then we set DP to C8 again. What's this here? LF637. LF637. Okay, so it's some address inside this routine, which is a rotates a vector list. So this may be related to rendering the board, or maybe rendering our ship in the middle. In either case, neither one of those are being really rendered properly. So that's kind of interesting. So we come back from that. Move draw VL AB. Come back from that. C8. Once again, LF637. Now it's difficult to know from here whether we're really trying to draw. We seem to be in some kind of loop there. C8BA, which has 1 and wants to see if it's 0. It's not. Another call there. Draw. Oh, hey, thanks for the follow, Spock. Appreciate it. Yeah, this code is starting to look all the same. What's this here? C8F8 offset 7 into Y, C8FF. Compare it to C922. Branch if less than to AD to 0BC6. Not quite sure what this code is trying to do. Oh, look at this. RTI. That's interesting. So this would be an interrupt service routine. Just thinking about how right now it looks like we're in an interrupt service routine here. We're processing an interrupt. That's very interesting. I'm trying to think, how do I know? I should have written all the vector table here. Let's get the different. I'm gonna guess this is the IRQ one. So let's go take a look and see if we're right. FFF8. So if we print P, right? I think it supports 0xSF. So 0 FFF8 and 9 is CBF8. Now if we print CBF8, 7E, that should be a jump instruction. And then F9, so that's 7E09. So 7E is usually the jump. Let's see. And it's actually 3 bytes, so it's going to be 09 followed by FA, 09B9. Let me just make sure. 7E is jump. Yeah, jump. So when IRQ happens, it's going to jump to 09B9. 09B9. Let me write this down. Can you check the interrupt vectors? So Pyro, you and I had the same idea. Looks like we're in sync, you and I. Okay, so IRQ vector jump to 09B9. So let's see if we go back to our trace. Okay, so I have this here, so 5166. (51.166) actually. All right, so let's see 09B9 searching upwards. So all of these are interrupts that are occurring. Yeah, no problem, man. So we see this happens actually quite a bit. Looking here, I have 1, 2, 3, 4, a few different instances of it. Now, in terms of where we were, 51166. Yeah, let's look like this. So I guess it's this one here. Oops. Five 11171. I'm not formatting this one right. It should be 04. Okay. Wait, is this right? No, it's not right. 09. Okay, it's here. What's this? Okay, this is nothing. All right. So this code that runs in the IRQ takes care of music, it seems. And then it's looking for bit A, 0D. It's looking to see if the timer is set. Otherwise, vec refresh, recalibrate. Huh. So it uses this interrupt to recalibrate. That's interesting. That's very interesting. Because I'm wondering, because recalibrating basically is something you do once per frame, so maybe that's what's using this ISR for, and it would bring the beam back to the center. So what we might have here is some kind of race condition. That's my guess. Something maybe with cycle timing that's not quite accurate. Could this be? This recalibration is very long. This is where it does this, yeah, this whole waiting for the timer to elapse, resetting, all of this. This is very, very long. It also reads buttons in here, eh? Looking for button 1. That's kind of surprising. Unless what it does is it queries the buttons and like writes them into memory so that it can be used later. Let me see. Store A, yeah, it's possible. It's getting the button state. No, sorry, this is all read buttons. So it's calling read buttons. Intensity, brightness, all the stuff we saw before is happening in this ISR. Where are we? Okay, it went too far. Just give me a sec. Tools, options. to put the map here. You know what I'm going to do? I'm going to actually copy this into a new file because it's kind of difficult. So what it looks like is, to me, I would say that the ISR for this game does the game logic. That's what it looks like. Let me check which. So we know that it's calling this IRQ, like this IRQ ISR, but what again is it looking for to know whether it needs to? I don't know if we'll be able to know. I don't know what the enable register is. Oh, that's interesting. Oh, that's yeah. I just realized something. This instruction before we make the ISR jump ends up looking as though bit A0D. This instruction ended up pushing a bunch of stuff to the stack, but this is because of the jump to the interrupt. This is pushing the state of all the registers. Could that be used for me right now? So I want to know, I can't know what caused the IRQ to occur. Yeah, so basically what I'm not getting here from my debugger at this moment is what exactly caused this interrupt to occur. Oh, thanks for the follow, Cookie Bow. Appreciate it. Now, that may be true, but I should be able to at least figure that out by putting a breakpoint on when we are at CBF8, right? Or do we want to do it before then? I guess I can just put a breakpoint right in my CPU here. Hopefully it's not too heavily optimized. Right here. Let's continue. Alright, so we've hit our interrupt. Interrupt mask is 0, IRQ enable is true. Now let's see if we can tell why, what exactly caused IRQ enabled to be true for us. So if we go on the VIA chip here, like if we take a look at IRQ enabled, what it does, yeah, this is a bit annoying, but actually what we probably just want to do is see what get interrupt flag value. That's it. Okay. So we just want to know the result of this get interrupt flag value. Surely I won't be lucky enough to be able to run it. We're gonna have to do it ourselves. Oh, well, what do you know? Thank you, Visual Studio. Okay, so get interrupt flag value is returning this sequence of bits. That's very interesting. And then interrupt enabled. Okay, so this is showing. All right, I see. So this shows all the bits, all the bits that are on except for bit 7 here are which interrupts have occurred. But the one that we're interested in is the one that the interrupt enable flag has on. The fact that it's 20 tells me it must be timer 2. Okay, so that kind of makes sense actually, because timer 2 is the timer that's typically used for syncing on the 50 Hertz. And so in this game, what they do is they have an ISR that fires basically at 50 Hertz. And they do all their game logic in there. Kind of interesting. Maybe that's a way I can compare the case of when it's not working to the case where it is working. Because we were able to extract the full ISR. That's pretty easy to do from the trace, given that it's doing it through an ISR. So maybe what we can do is, yeah, we can take this code here, this trace here, I should say, where it's not working, and compare it to an ISR for when it is working. That could be interesting. Yeah, let's try that. So let's reset. Maybe this will help us. All right, so I'm gonna hit go, and then I'm going to pause here, and I'm gonna grab a trace. And we'll put it in trace working text. So let's open that. And let's look for our IRQ ISR. So we're looking for this kind of jump here. There's one. But actually this is CWAI. Interesting. We did not see this. So in the case where it's working, we are waiting for an interrupt actually. So maybe that's all the difference. Right, we don't have a CWAI in our other trace, right? No, we don't. Aha. That's it. That's right there is a very important hint. I'm gonna guess, yeah, we've got CWAIs all over the place. So it's CWAI EF, which means what again? That tells what bits we want to set, right? Give me a second. There's like only really 2 cases, if I recall, for CWAI. So wait for interrupt. We read this value. Oh yeah, and oh yeah, that's right. It's a mask to AND against CC's value. So what we want to do there is we want to keep all the bits on except one of them. That's what we're trying to do. So it was EF. So we're trying to turn off bit 4, is it? Yeah. Bit 4. So what's bit 4 in terms of our CC register? So 1, 2, 3, 4, no, 0, 1, 2, 3, 4, interrupt mask. Okay, so that's it. We are waiting for IRQ. That's exactly what that means. So in the case when we're working, we're always waiting for the IRQ. So it's like basically what I think this means is that in the normal case, see I is low, we do a whole bunch of stuff and we reach an instruction where we say, okay, now we're ready for that, like we're done our work and we're waiting for that interrupt to occur. But in the case where we start again, we're not actually running this code, or at least we're not reaching here. And that's, I think, is because I isn't reset. I still come back to that. I still come back to this notion that I must be reset. That is a big clue right here. I was going to compare. Okay, let's just compare anyways our ISR. I am interested just to see at least if the ISR kind of lines up, but I don't think we're going to find our answer right there. Okay, I'm going to look for RTI from here. 37004. RTI. $42654. All right, so let's try and actually select that. That's one thing I can't do in Visual Studio is I can't do like mark selection. Right? No. It's okay. 37004. I'm going to open Beyond Compare. I'm going to say working case, paste this here. And we're going to copy the case where it doesn't work on this side. Hopefully Right. For sure there's going to be a lot of differences in the initial state. But we can see it's mostly the same. I mean, obviously there's going to be some differences here because at one point it's going to do this vec refresh and we're going to become out of line. It depends on where the timer is at the moment we do this, but that's okay. So here we do a recalibrate, and then this is where they're going to differ. Strangely, not that different though. Let's see. Not surprisingly similar. And in fact, then at one point it becomes exactly the same. So there's a value at C824, which is the Vec0ref enable, that is slightly different. That's probably okay. Okay, yeah, it's one of those odd even 1-2 values that just toggle back and forth. So we're just off sync here. One is on an enable, one is on a disable, I suppose. Yeah, that's okay. Oh, this is interesting. C8, C8. In the case where it works, it has this 6 value in there, whereas here it has a 0 value. What would it use this for? Loads it into B, and then it calls move draw VLAB. So obviously it wants to use the values in A and B here, where in the case where it's not working, B is 0. So let me just see what this is. Vector list AB. Just double check what that means. see here. This routine moves to the first location specified in vector list and then draws lines between the rest of the coordinates in the list. The vector list has the following format: A-reg, number of vectors to draw; B-reg, scale factor to use. Well, a scale factor of 0 would mean we would not see anything. So that's interesting. C8, C8. Like, I'm wondering if that's the scale factor that's used to draw the map, you know, and maybe this is a value that shrinks over time. And in our case where it's not working, maybe it didn't get reset to something because because I assume it has to do with the interrupt flag not being reset properly. And so we don't get to run the code that kind of like resets this value. I'm gonna guess that C8, C8 is that. Let me take a little note here. Scale factor for drawing the map. Okay. Okay, and that's just the difference between the Vec0 ref enable. Let me just check what this actually, maybe we have a comment as to what this might mean. Don't reset the 0 reference yet. Restore old check 0 ref. Check 0 ref enable flag. Check 0 ref. This routine will check to see if the reset 0 ref enable flag is set, and if it is, then it will reset the integrators by calling reset 0 ref. So this enable flag basically tells it, do we want to be able to, do we want to reset the vector back to the center? Is it strange that it becomes 2? Because it looks like in the code it wants to clear it. So it feels like it would be either 0 or 1. But in our case, it became 2 when it wasn't supposed to be working. So that's curious as well, the fact that it's 2 here. It's like I would have expected it to be 0. 0 or 1. And then we get to the bottom here. So what have we learned? We have learned that for the most part the ISR is the same. Where they seem to differ, one is the scale factor is 0, so that's possibly part of our problem. Hey, let me follow this value in the code where it's working just to see if it like gets smaller over time. So here we stored 1 into it. It was 0, then we stored 1. Here we stored 2. Because we do this increase A, and then we write to it. Then we write 3, 4, 6. And then it's 6. And do we even reference it in the other trace? In the trace where it's not working, it looks like we never reached that code that actually increments it. Let me see, where is it incremented? Here. 01DE. Nope, never reach it. Oh, take it easy, Lisp gamer. So, okay, one thing I'm interested in maybe in trying now is instead of diffing the ISR, to try to diff the code between the ISRs. That might give us another clue. So let's see if we can do that. This is a trace where it's working. So let's say we go, this is where one ISR occurs. Now we look for RTI. So here we're back. Let's look for the next begin ISR, so that's CWAI. Well, technically, it's more like jump 09B9. Or the CBF8. Yeah. RTI there, and then CBF8. So that's the next one here. So we want all the code between those two. 8543. So let me write this down here. And of course, you know, so in this case, it makes sense that we can grab that code in between, because if it gets to a point where it actually waits for the IRQ to happen. Whereas in the case where it's not working, that IRQ just happens like randomly at some point, because we're completely off sync. We're not running the code correctly. So I know that grabbing the code for the not working case, I may not get the right thing, but it's okay. We'll see what we find. So, all right, so what was I saying here? It's gonna be from 8543 to, wow, it's very short, 8577. It's really short. That's it? I can even see it on one screen. So is that always the case? Let's take a look. 0FF RTI. Okay, we're looking for 0FF and we're looking for 0FD. The CWAI. Yeah, there it is again. See? So this is really the only code we're expecting to run in between those two instructions. Where is the next one? Here. Okay, that's very interesting. 0FF. So do we get the 0FF in the case where we're not working? Yeah, we really don't. Okay. Let's try something. Let's run this 00FF to 00FD range here. It's very interesting. It's the little bit of code. I'm gonna write this down. When working, Bedlam has this short piece of code. It runs between IRQ ISRs. Between the IRQ ISR from so let's see this. If we reset and put a breakpoint on 00FF, let's see what leads up to that code, and that might be something we can look for when we we can kind of like analyze the code that leads us to getting to this 00FF, like what makes us jump here, and then maybe work backwards from there and try to understand maybe what the game should be doing when we say we want to start a new game, and what it's not doing on the second round through. I think that could be the strategy to figuring this out. Going to reset here. I'm going to put a breakpoint on 00FF. Okay, I'm going to hit go, and there we go. We hit our breakpoint. Now, I don't know how much of a trace we're gonna need, but let's say, let's put 100,000 as usual, and I'll say trace working new game or start game dash F. I don't know how easy it's going to be to read this, but we'll make do. Okay, let's get to the bottom here. Am I still having neck pain? Yeah, a little bit. But it's better. It's a lot better. One thing I realized is that, like, my setup here at home, my monitors are nice and high and they're at the right distance for me, so here it's fine. I can actually sit here for a long time and feel fairly comfortable. But at my, where I work, my monitors are on these arm stands and they have they're not very long, so I can't put them as high or as close to me as I like. And so they're a little bit too low, and so I find myself over time when I'm staring at my screens, I'm like moving my head down so that I can kind of line up my eyes with the part of the screen I want to look at. And then I do that for such a long time, I start to feel this neck pain. So I think I figured out the source, because we got these arms not that long ago. So yeah. I'm gonna see what I can do about that at work. I'm just a little bit surprised here that we hit 00FF while waiting for this interrupt service routine to occur. Which maybe means, what does that mean? Oh, I think I know what this means. That's kind of funny. Okay, I think this is more an issue with my debugger. The CWAI is really an odd instruction, and it makes my debugger, like I have to do these kind of contortions in my debugger to make things work. So the issue is that actually FF here is an instruction that must follow FD, right? Because it's 2 bytes, so it's going to be FE and FF. And so here we're supposed to be blocked on FD and not move forward, but my debugger says, oh here, oh hey, like I guess PC must be FF right now, which is probably wrong. Is it wrong? I don't know. That's what I mean. CWAI is such an odd instruction. Let me see something. Like, what does the CPU do? Does the PC still move ahead when it executes CWAI? I don't like this instruction. Because it messes up everything. Yeah, so we can see PC actually. It's the PC is this. It's 00FF. It is indeed that. I mean, the way I handle CWAI is like I handle anything else. I move PC ahead to the next instruction, like you expect the CPU to do, right? But maybe what I need to do is I need to really have a special case for CWAI and not move it ahead. I don't know. Like, I really wonder, what does the CPU really do? When it executes CWAI, does PC move forward? Anyway, I could decide not to move it forward, which probably would be fine, because in any case, what we do in that case is we're waiting for an interrupt to occur, and then we replace PC with whatever's in the interrupt table, like right here. So basically, if you see here, like in the normal state of affairs, we don't do this, we don't do this. We come here, we figure out which op we want to run, and yeah, so we don't see it here, but reading from the PC moves the PC forward. So this block of code up here, which reads the instruction bytes, will move PC forward, which would make sense. Hey Blue Dragon, how's it going, man? You're saying I should stay there. So I could like there's another way to approach this, which would be a bit of a hack, I suppose, but it would be to say, I hate these hacks, but something like I could do it in here. Push CC state, and then I can do like PC, minus equal 2 bytes or something. Knowing that it already had moved ahead just to read this instruction. When you think about the hardware for how the CPU works, it's gotta have moved forward. That's just once it reads an instruction, it moves the PC forward. It is just a visual bug. It is. It's more like my debugger would have to have like special case logic that's like, oh, if you set a breakpoint and we're waiting on CWAI, don't hit the breakpoint. But that's not right either. I bet you, yeah, it's just a pain to use the breakpoint, exactly. Okay, so let's try something. Let's leave this alone. Did I like save or something? Oh, that's annoying. Let's leave this alone. Let's continue. Interesting. So, oh, sorry, Blue Dragon. Just finished drawing practice for the night. Figured I'd check in on some Vectrexy before bed. Oh, thanks, man. Yeah, I'm probably going to be stopping soon, actually, because I haven't been sleeping much these past few days, so I just wanted to get some sleep. But, it's interesting. Okay, I see what's happening. We're not moving forward. I keep hitting my breakpoint because every time I execute the next instruction, which is really not really executing it, it's returning that we are at 00FF. Okay, so let's try hacking this. I guess the question is, logically, you know, when you execute a CWAI on a real 6809, what does the PC look like? You know what I mean? But let's try this disgusting hack and see where it goes with. So now, it says I hit a breakpoint here, but this is the real deal. So there we go. So this is, where are we now? Oh, interesting. Right, so the very first time we hit it is after having executed the interrupt service routine, which I suppose makes sense, right? Because we were waiting on it before, then we execute it, and then we come back to the next address. So that makes sense. Okay, so that makes sense. The very first time we hit it means is right after the very first time we run that. Let's go back to that file. So yeah, we just, what was the name of the file again? It's up here. Trace working start game. Alright, so here we are. Now there's going to be a lot of noise at the top here somewhere because we hit start and I've got to find where the real thing happens. Let's see if we could figure it out. It's going to be probably the first time we have this 0 address here. Could this be it? Oh, and I forgot to load my symbols again. See? So I'll say it again. I really need this auto load symbols junk in my debugger. All right, let me reset this. Enable 0. Dump again. This time we'll have symbols. Okay, so here we are. Yeah, so you can see here, it was waiting for button 1-4, could it be? Although actually we pressed, it should be button 0. No, button 1-4, yeah. That's how we start the game. So this is the beginning right here. And you can see one of the first things it does is it deals with interrupts. It stores the value of A into interrupt enables. It wants to store A0. So yeah, that's saying I want to enable, that's the top bit here, the interrupt for timer 2. So that makes sense, because that's what it uses. It then says I need to store CBF8 into the IRQ. So this is loading up the ISR into the IRQ vector. So this is storing store A. So actually A is jump. You see it put jump into A and storing it there. Then it's going to probably put the next two addresses 05, or is it increment A, load B 05, load X C8 D4, clear XBA. Wait. Oh, here it is. Oh, sorry. Okay. Beforehand, it writes 09B9 at CBF9 and CBFA, and then it puts the jump. So this is where it sets up the ISR. Okay, then it's some clearing. So there's not too much code, which is kind of good news. Let's say I just delete all this at the top here. Just to keep this nice and simple. I just want to see how much code we're dealing with here. Yeah, not too bad. So there's something in here which I assume there's a subset of this that needs to happen again when we die and we come back to the start screen and we say go. That's not happening. Actually, let me bring this back for 1 second. Just had a thought. In fact, 004F. Do we hit this breakpoint when we die and continue? Let's try that. Let's disable this one. And we'll put a break on 004F. And then let's die. Okay, and we come back to here and we hit F. And we do hit it. Ah, so this will be interesting to compare, won't it? And I mean, right there you can see the I flag is 1, whereas for us at this moment it's 0. And this to me is the cause of all our problems. In fact, now if I set it to 1, maybe it will see it work. Yeah, let's try that. So let's put a breakpoint in execute instruction here. Step. Why didn't we go into execute instruction? Yeah, why isn't this working? Okay. We did change CPU, and I think it might not want to go in there. Normally, though, it gives me a warning that it can't. Oh no, okay. This is putting when you put a breakpoint on a line that contains a lambda, it's setting a breakpoint inside the lambda body. That's why it's not working. Okay, here we go. I don't think it's too late to do this. So let's try now setting interrupt mask back to 1. So now you see it's capital I here, and let's see if this works. And it works. Okay, so my theory that there is something that needs to reset I back to 1 seems right. And now it's just about figuring out why, like what it is that's supposed to set it back to 1. Actually, okay, I'm just gonna write it down. When you press button 1, no, sorry, when you press joy, stick 1 button 4 to start a new game, the game code starts at 00F. At this point, the I flag should be 1. No IRQ. This is reset. Sets I to 1 for the first time. Damn it. This works. But after we die, when we press joy 1 button 4 again to start a new game, the I flag is now 0. I'm just thinking that it's kind of surprising that it's 0 at that point. And the reason I say that is that, you know, when we're done processing CWAI, we set it back to 1. And when we're done processing this IRQ, you know, it was 1, it got set to 0. We pushed the CC state and then set it back to 1, so it cannot be. Wait a minute. Maybe that's the bug. Let me think here. Wait a minute. Does this make sense? When IRQ is enabled and we allow interrupts, we end up saving the fact that the interrupt mask is 0 on the stack. Then we prohibit any further interrupts during the time we process it, but then when we're done the interrupt and RTI occurs, we're going to restore the state and the interrupt mask will go back to being 0. That's probably wrong. Let me just, swap these two lines here. So by doing it this way, when we're about to process the interrupt, we reset it back to 1, we push it, so that when we restore it in RTI, it remains 1, which is probably what we want. That's probably why it's still 0. It's like always 0. And we're just kind of lucky. Because the only interrupt we care about is the timer 2. Let's see. Yeah, so this is working. We die. And it works! There we go. Yeah, that actually makes a lot more sense. Hey Raptor. So you see, this is my rubber ducking right here. In trying to write out a situation, something clicked in my brain. I was like, wait a minute. Why is it 0? When I was writing the sentence here, I'm like, at this point, I is 0 now. I'm like, but why would it be 0? We always reset it back to 1. I'm like, don't we? And then I looked here and realized, no, we don't. I had this the other way around. So we would always restore it back to 0, which is totally wrong. I think Notepad's a pretty good duck. Don't you think? Yo, I'm so happy this works. And of course, it's like a 2-line change. It's a line swap. That's our fix. All right, well. Oh, nice. Yeah, it's always like that, right? Spend a ton of time debugging to figure out the thing, and then the fix is always so small. Yeah, exactly. Okay. Oh, thanks, man. Okay, so I'm gonna stop here, guys, because it's actually half an hour later than I wanted to stop. But thanks everyone for watching, and yeah, should be back on normal schedule. So next week on Monday, I should be streaming again. So thanks again for watching, guys. Catch you next time.